properties. Okay, now I think we have audio. Thank you, Richard, for telling me. I had no idea I had no audio because I wasn't looking at my meter. So thank you for telling me. Well, okay, so the first several minutes of this here, you guys heard absolutely nothing I said. Excellent. So let's start all over again. This is what I'm using for my scope. It's an 8-inch Schmidt-Cassegrain telescope with a camera stuck on the back, and all riding on an AM5 mount, and all riding on my spare no expense cinder block up here. So this is what's bringing us the pictures tonight, along with a 183 camera, and yeah. Let's see. So this first object is NGC 3132, which is a planetary nebula, obviously. And the reason the reason this is so incredibly low, and it's only about 5 degrees above my horizon, it's very, very low. But it's because he intended it for our southern hemisphere folks. But luckily, me down here at 36 degrees latitude, I'm able to get it. It's kind of a cool looking one. Balance these colors again a little bit. We can probably even back this off a tiny bit. See a little bit more detail in it. Yeah, that's actually a little better. That's a pretty cool shape in that. Okay, let's see if Wikipedia has any more information on this. NGC 3132. It's called the 8-burst nebula, or the Southern Ring Nebula. Bright and extensively studied planetary in the constellation Vela. Its distance from Earth is approximately 2,000 light years. Southern Ring Nebula was one of the 5 cosmic objects observed by the Webb Space Telescope as part of the release of its first official science images on July 12, 2022. This one was part of that. Cool. Images of 3132 reveal 2 stars close together within the nebulosity, one a 10th magnitude, the other 16th. The central star of the planetary nebula is a white dwarf and is the fainter of the 2 stars. This hot central star, about 100,000 Kelvin, has now blown off its outer layers and is making the making the nebula fluoresce brightly from the emissions of its intense ultraviolet radiation. Okay, let's start the background music too. Get that going. just barely got this one. Just barely. This one's going to be in a building, so I won't be able to do that. We'll go for 2537 next. Caldwell 31 is also too low. Yeah, this is the Flaming Star Nebula. That's a winter nebula, which means that's for the southern hemisphere, folks. I'm not going to be able to get that one. I'm quite surprised I'm able to get this one, honestly. It's at the extreme low. Low, 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 low on the horizon. 2537. This one will be next. The Bear Paw Galaxy. That will be next. Okay, well there's 10 minutes on the 8 burst planetary nebula. Kind of a cool looking one. This is a star going through its death process, blowing off its outer layers and illuminating them as it blows them off because its core continues to glow. Our sun will do this in about 4 billion years. So, but it makes for some pretty objects. Okay, let's go to 2537 next. Alright, let's go over, let's get off the horizon here. Swing on over up there, yeah, that's in a pretty good spot. We may catch some satellites on this, but we may catch some satellites. On the western horizon this soon after sunset, but we tend to catch the low Earth orbit satellites out here. And you shoot west within a couple of hours of sunset, so we'll see. We'll see what we get. Okay, looks like you are. Alright, so this is 2537. What did 2537 Bear Paw Galaxy, a blue compact dwarf with knotted star-forming regions. Okay. It is hollow 25 million light years away, so not very far away in galactic terms. Not very far away at all. See that bear paw in there. That's pretty cool. Alright. Oh, we got a bonus down here too. We got a bonus. Second spiral galaxy, an edge-on spiral down here too. And then the bear paw up there. It's a dwarf galaxy, huh? Not a nebula, it's a dwarf galaxy. Isn't that interesting? This is IC 2233. And more, ooh, there's a nice little galaxy in there, huh? Most of these are just ellipticals, but that one looks like there might even actually be a little bit of structure in there. So once we get a few subs in, we'll zoom in on that and see what we get. Okay, anyway, this is 2537. Let's 2537. the Bear Paw or Bear Claw galaxy. It is a blue compact dwarf galaxy in the constellation Lynx, located around 3 degrees. Blah blah blah. Discovered in 1788 by William Herschel. He discovered a lot of stuff. It belongs to the IE class of blue compact dwarf classification, which is described as galactic spectra with an underlying smooth elliptical low surface brightness component. It was long thought to be possibly interacting with IC 2233, the galaxy down here. However, though they may lie at the same distance, neither display the hallmarks of a mutual interaction. Okay, so they're about the same distance away, but they don't seem to be interacting, apparently. Alright. Good evening, Elle. Thanks for being here. Right now we are doing the Bear Paw or Bear Claw galaxy with friends. There's a John Spiral galaxy there. We've got a few other little galaxies in here as well. So there's several in this image. In fact, let's stash that out of the way. Get in there a little bit closer. There's definitely a nice little guy there too. Looks like a ringed galaxy with a ring around it. Yeah, we're having a great evening here as well. We've had beautifully cool weather these last. Our spring is we're having a nice long spring, which is unusual. Usually we get a week of spring and then it's right into the heat, but it's we've been having some beautiful cool weather here, and it's been very nice. So we've been in the low to mid 80s this weekend, and it's going to start warming up now this week, but it's been so nice and cool up to this point. It's you can easily be in the mid hundreds. 105 plus this time of year for us. In fact, that's where it's headed by the end of the week, they're saying. So our heat is finally looking like it's gonna show up, but it's been a gloriously cool spring. We've really been enjoying it. So tonight is just very comfortable, clear, calm. Not hot, but just sort of comfortable. Just out here in a sweatshirt and sweats, and it's just very comfortable. No breeze, which is nice. Our biggest bugaboo out here is wind. With no trees, there's nothing to knock the wind down, so we do get a lot of wind out here. Alright, we can probably kick that histogram up a wee bit. See more of that detail in there. Yeah, we're getting a nice little core in 2233 here. Some core showing up there, maybe a little bit of dust lane in there. Hard to tell. So it seems it's a little uneven in shape. According to Wikipedia, these two are not interacting. The dwarf galaxy and this galaxy are not interacting, but I don't know, this looks a little wavy to me. It doesn't look perfectly flat, but you know, they look at it with much better telescopes than I have, so. And here's this little companion here. What was the name of this one? NGC 2537A. Huh. And this 2537 proper. So I don't know. Do they assume that it's a satellite of the Bear Paw? Not sure. Did they say they're 25 million light years away, or was that the last one? Right ascension, time, apparent size. It says the two of them are at the same distance, but it doesn't say how far away that is exactly. That's pretty cool. Bear claw. The bear claw. Okay, so what's next? Those are too low. This is too low. So, what do we got next? 4361, 4314. Well, we're already up here, so let's just do 4314. What am I doing? This 4314. Boink. Alright. Good night, Bear Claw. And let's go to you. Right up top. Okay. Let's plate solve on that, maybe. Okay. Let's see what. See what we can see here. NGC 4314. Let's see what he has to say about this one. 4314. Barred spiral, notable for its surrounding ring, about 2,000 light years in diameter, that glows with bright blue young stars in active star forming region. Okay. Approximately 53 million light years away, according to Wikipedia. Galaxy was discovered by William Herschel. It was labeled as peculiar by Alan Sandage in 1961. Because of the unusual structure in the center of the bar. Okay. Let's straighten out a little bit here. And we definitely have a ring around here. It's a member of the Coma 1 group of galaxies. It's a barred spiral with very tightly wound spiral arms. It's inclined at an angle of 21 degrees to the line of sight from Earth. The bar extends out to a diameter of 76 arcseconds before joining the spiral arms. These trail in 130-degree arcs out to a radius of 125 arcseconds from the nucleus. Outside the nuclear region, the galaxy is considered generally gas-poor, with no hydrogen and beta regions in the outer spiral arms. Okay, so the outer ring definitely got some friends around too. Alright, well, definitely a swirly bar in there. Let's see what they got. I think they got a Hubble telescope image here in Wikipedia, which does not look a whole lot like what I've got here, because it's a small little guy and requires a lot of time sitting on it to really see much. You can see the wispy outer part here, but this is an object that would take some time to sit on and really bring out the fainter stuff. But the central core and the bar definitely just show up really nice. So, that's pretty cool. It's a prominent ring of star formation around the galactic nucleus with a radius of 9 arcseconds. 76 open clusters of stars have been found associated with this ring, and these are probably due, at least in part, to Lindblad resonance. Most of these clusters are 15 million years old or less. The current burst of galactic star formation is estimated to have lasted 30 million years. External to the ring, the stars are generally older than within the ring structure, suggesting a previous epoch of star formation. Yeah, my image and the picture there don't look the same, but well, it's a pretty cool barred spiral anyway. Wispy arms coming off. We're just going to catch things as they come across. he has more in his list. I just I collected the first dozen or so, just because I thought that's what we'd have time for tonight, but it looks like some of these things that I've chosen are actually Southern Hemisphere things that I'm not going to be able to get. So, let's see, a couple of these are too low. We got 74 just before it disappeared too low. But this one here, 54, is definitely not going to happen. 31's not going to happen. Flaming Star up here is not going to happen. It's too low to the north for me. So we're just going to catch these few as they come across. Got 4 or 5 of these. Got M13. Got this here, which is another southern object, but this would be much later for me. That's a southern hemisphere object. This is a summer object that would be up in several hours, but I'm not going to broadcast that long. Just starting to have the inner ring show up a little better. The wispy arms outside it. But this one definitely needs a lot more time than we're going to spend on it tonight. cool. We might give this a couple extra minutes. So I'm going to bring out a little bit more of this outside. About 12 minutes or so on it. We definitely picked out some of the wispy stuff and a nice barred structure. Almost starting to get some detail in that too. Okay. Moving on. Who's next? C4361. Lawn Sprinkler Nebula. Back down to the south. Back south. Galaxy-like spiral structure resembling a lawn sprinkler rides low on the southern horizon but may still be accessible for those not too northerly latitudes. A Wolf-Rayet star resides in the center of this small bright planetary nebula. Look for the spiral quote-unquote arms. Okay. $43.61. Central star is an extremely hot Wolf-Rayet star. Its temperature is 126,000 Kelvin. It is nearly 18,000 times brighter than the Sun. but is only 6% of its size. Star left the asymptotic giant branch. It's 6% the size of our sun, but 18,000 times brighter. That's just crazy. It's a pretty hot star. Just a little bit here. Take the noise down just a little. Definitely see the little arms sticking off it. Looks like it is a galaxy spinning there. About 3,400 light years away. Hey, good evening, Dean. Thanks for stopping in. Yeah, it's been a minute since I've been on. We've been having actually we've been having atypical spring weather. It's been beautifully cool. We're having an actual real spring, a long spring. I mean, it's been cool, right? I mean, like I was telling these guys earlier, this weekend was in the low to mid 80s. That is incredibly cool and beautiful for us here. Normally we're about 20 degrees warmer than that. In fact, by the end of this week we're supposed to be in the mid 100s. So we've been having just a really nice spring here. And but yeah, springtime is usually windy and who knows what's going on. I haven't had much in the way of any rain or that kind of thing, but just lots of wind. The cool weather brings unstable air, so we tend to get a lot more wind when it's cool than when it's warm. Part of the reason why it's great astronomy weather tonight and probably tomorrow night is because it's warming up again. So we're going to be 105, I think they're saying, on Thursday. So warming trends usually result in nice astronomy. So that's why I'm out here tonight, because it's pretty nice astronomy here at the moment. Do I have my flat in there? Yes, I do. Very good. Yeah. Good there. Okay. A Wolf-Rayet star, which are just super hot stars. But they do create some spectacular nebulosity around them. They burn so fiercely, I guess they just blow a lot of their material out as they burn and fluorescent. Thanks to whoever gave me the thumbs up. Just noticed that. Much appreciated. Always good to get the YouTube love. What else is? I don't think that's anything yet. It's pretty short right up on this. Not a lot to say about it. Good evening, Eli. It's going great here. Having a nice astronomy night. So, we're out seeing some stuff. Thanks for joining. Stuck grading papers. Well, unfortunately sometimes life gets in the way of astronomy. It shouldn't be that way, but it is. Sprinkler Nebula. Very cool. Let's go to 4761. Well, it's right here. Let's just hit it. 4759. Yes. Same thing. So, we've already done this. Let's just pop up and get it. 4761. Okay, so this is part of the Hickson group. It's a compact galaxy group. So they're all just gonna, there's quite a few in here. But all the ones we're looking at, there's the Hickson group right there. These are apparently the ones that we are most interested in. So we can get more of them separated. 4764. Not resolving individual galaxies, but there's quite a few in this image, obviously. Quite a lot. Let's see if I have 76 in here. No. 78. Nope. Let's try Hickson 62. Nope. Wikipedia's never heard of any of it. Oh well. It certainly is a screen with a lot of galaxies in it. A scene, a field of view. Eli asks, what's my field of view? Well, let's put it here into Stellarium, because Stellarium has 183 and the C8 at f6. And so it's about 37 arc minutes by 25 arc minutes. So a little over half a degree by a little under half a degree. So I guess you could say about half a degree. I think when I've got the hyperstar in, I'm like 3 degrees by 2 degrees, or 2.5 degrees by 2 degrees, or something like that. Okay. Alright, let's see what's next here. We've done those. Okay, we did 4314, but we did not do 4676. So that will be next. But there's the Hickson compact group with plenty of friends around. Lots of galaxies in here. Lots of galaxies in here. But let's move on to the next thing. 4676. Let's center that up. Move us on in. Should be about right. This is the mice. Oh. 2 spiral galaxies in Coma Berenices, about almost 300 million light years away. So. Okay. So this is the mice galaxy. So these 2 little guys in here with their long tails, which will resolve here after we've collected a few subs. But they're about 300 million light years away, so they're quite a good distance away. They have just begun the process of colliding and merging. The name refers to the long tails produced by the tidal action, the relative difference between gravitational pulls on the near and far parts of each galaxy, known here as a galactic tide. It's a possibility that both galaxies, which are members of the Coma cluster, have experienced collision and will continue colliding. It's a possibility that both galaxies, which are members of the Coma, have experienced collision and will continue colliding until they coalesce. That's a little awkwardly worded. I guess they've been colliding for a while, and it will eventually just coalesce with each other. Galaxies were photographed in 2002 by Hubble. In the background of the mice galaxies, there are over 3,000 galaxies at distances up to 13 billion light years. There's a lot of stuff in these images. We're going to need some resolving time on them, though. Especially at f6. It's going to be a few minutes before we can get some good data on them. definitely getting one mouse tail. This one's being a little more shy. We may give this a couple extra minutes again. Yeah, this one just kind of curls around and does this. I'll give it a couple extra minutes. See if we can resolve a little bit more of it. Risk of making it a little noisy. Let's see if this. Yeah, we'll do that. Yeah, it'll make it a little noisy, but now we can start to see a little of this tail coming out here. Two galaxy cores. There's 3,000 galaxies in the background of this image. Far fainter than what my little scope can pick up, but we got the mice. This top one definitely looks like a mouse. Long straight tail coming off the back of the little body. This one here is a little bit more of an antenna or wing or something. Definitely there. Two colliding galaxies. The interesting thing about colliding galaxies is there's so much distance, but I mean they look like thick, dense, objects full of stars, but there's so much distance between all the stars that when galaxies collide, it's extremely rare for any particular star to actually collide with another star. Usually it's just gravity that tears them apart, and there's actually very few collisions in galaxies of billions of stars, hundreds of billions of stars colliding. Cool, well there's that one. Okay, what is next here? 4761 we did. Isn't there another one in here? I thought there was another one in here. I thought there were three up here. Oh, there is. It's 5394. Which has not actually come across yet. So we've done everything on this side of the meridian. These guys are very close to the meridian. Box galaxy, that's what it right close by, we can do that. Oh, the Silver Needle, that's also a nice one. Yeah, let's do the Silver Needle. It's not on the list, but it's a nice galaxy, so let's do it. Bonus. It's right next door, so bonus object. We'll wait for these guys to come across. We'll just stay over here. We'll just stay on the west side of the meridian. Okay, let's get you. Plate solved. Thing's right there. Okay. Very good. Go. The Silver Needle, 4244. This is a good one. I like this one. The Silver Needle. It's about 14 million light years away, so that's pretty close in galactic standards. The nuclear star cluster and halo is located in the center of the galaxy. Alright. As opposed to the little tiny things we've been shooting, this one will be a significantly bigger object. Well, let's just leave it where it is. Back this off. Make it a little less noisy for a minute. While it does some resolving. But this is a pretty nice galaxy. The Silver Needle. And you see 4244 for those keeping track at home. No, Cosmic. This is not the Sombrero. This is the Silver Needle galaxy. It's somewhat similar. The Sombrero has a bigger core, and we're not looking at it exactly edge on, so it looks like the rim of the Sombrero below the top of the hat. This one is the Silver Needle galaxy, and it's very much edge on. I think it's almost perfectly edge on. In fact, when we zoom in here, see just a little bit of dust lane going through here. So we're looking at it just about perfectly edge on. Sombrero is a cool one too. That's a very nice galaxy. My voice is not clear. Does it sound better now? I may have just gotten the microphone too far away from my my mouth. But let me know if that's better or not. Yeah, this microphone is pretty finicky. I think it's a pretty good noise cancelling microphone, so if you get it too far away from your mouth, it actually considers your mouth as noise it's trying to block, so got to keep it pretty close in front of you. But thank you for letting me know. Any kind of weirdness going on with the sound, do let me know, because I can't hear what you hear. So this is the Silver Needle galaxy. So it is NGC 4244 or Caldwell 26. It's called the Silver Needle, not the Sombrero is a different object. Similar, but the Sombrero has a bigger, fatter, better resolved core. This is very small, tiny little core. Sombrero has a much bigger core and a much more, much darker and more distinct dust lane going right through it, cutting it right through, and so it looks more like a. It looks much more like a sombrero. It looks like a hat. Okay, thanks, Dean, for the confirmation. Yeah, I mean, anytime the audio is weird, please speak up and let me know, because I can't until I watch the video the next day. I have no idea what I sound like, so I depend on you guys. Yeah, my Bortle level here is about 2.5. Not quite 3, but brighter than 2. I have Las Vegas is 80 miles to the east of me, so my eastern horizon, the first 25 or 30 degrees of my eastern horizon is kind of the washed out in the light bloom of Las Vegas. But that's blocked by my house anyway, so it doesn't really bother me. But the rest of the sky is pretty dark, so. Actually, I can show my gear again. I do that at the beginning of the broadcast, but that doesn't really help for people who don't show up at the beginning. So it's an 8-inch Celestron Schmidt-Cassegrain telescope, or a C8, as some people call it. And got the 183 camera stuck in the back here with a 0.63 reducer that makes it about f6 or 1200 millimeters of focal length. And all of it is being driven on an AM5 strain wave mount. All riding on my spare no expense cinder block pier, of course. And I'm at a table right behind here, running all of it, speaking to you now. So yeah, it's a C8 with a 183 camera stuck in the back. This picture actually has it with the Hyperstar in the front, which is what I use when it's not galaxy season. But right now it's galaxy season, so small objects and want more focal length. So there you go. Let me know if you have any other questions. Happy to answer them. Meantime, we'll finish up on the Silver Sliver here. yeah, basically the cinder block pier replaces the tripod, and because it's big and heavy and solid, it works very effectively. And there's 10 minutes on the silver sliver. Nice knot of star formation going on in there. And you can see just a little bit of a dust lane going through here. Just a little bit of one. We got any of our guys? No, still waiting for our next two to come across. I probably could have gone across and gotten them. We could do the whale next. Really just want to wait for these guys. And let's just go across and get it. Let's just go across and get it. Gonna be right up top. Very close. See. I don't see anybody in there. That will probably bring it into view. Still don't see anything there. Well, let's try taking this up and see what happens. Yes, Cosmic, sorry I didn't see your question. Yeah, you need to do a good polar alignment, which I can do. Oh, there it is, bang on. Which I can do right here in SharpCap. SharpCap offers a polar alignment tool right here, which just makes it pretty quick and easy. So yeah, I do a pretty good polar alignment before I get started each night, because I don't leave my things set up outside because it gets way too hot out here, especially in the summertime. So, Dean says he made a roll-off roof observatory out of a shed identical to yours. Oh, yeah, my metal shed. Yeah, I wish I could get away with that out here, but it's just too hot for anything that's not climate controlled. The electronics would not be happy outside in our summers. Yes, I do have a guide scope. It's not... I took this picture before I had it actually set up, but I mounted a guide rail up here, and there is a 60mm achromat little refractor telescope that's riding on top of here with a guide camera in the back of it. And so yes, that is what's doing the guiding that you're seeing here with that guide scope and camera. So which right now doesn't seem to be doing anything. I'm not sure what's happening here. Why is the guiding? Did the guiding not start? I don't know what happened there. Guiding reports that guiding has stopped. Guiding has stopped. Guiding has stopped. Well, it's going now. Oh, you got yours insulated. Okay. Yeah. Well, out here it has to be some sort of climate control. Electronics does not like to be used over 40°C and stored at over 50, and I exceed both of those in the summertime. So it basically any observatory that I set up would have to be climate controlled. So I just prefer to haul it in and out, which is why I went nice and light. You know, the AM5 is 12 pounds, and it swings everything around the sky that I have with no problems, and more than good enough guiding for me. So it does pretty darn good for me. So 0.5s to 0.7s, 0.8s maybe every night. Mostly 0.5s to 0.7. Sometimes as low as 0.3. Sometimes as high as 0.9 or 1. But usually right around the 0.5s, 0.6s. It only weighs 11 or 12 pounds, so it's very easy to carry in and out. My AVX that it replaced was like 50 pounds, including the tripod and the head and all of it. So the counterweights, all that stuff. So this is, I just got something that made it really easy for me to carry stuff in and out. And so it's just a few minutes to set up every night. So it works pretty well for me. Yeah, I probably should take another picture with the guiding hardware on it, so maybe one of these days I'll take one. Could have taken it tonight actually, but didn't think of it. But yeah, there's a rail on it with a guide scope with a guide camera riding on the top of this now, providing all the guiding. Yeah, that's a good suggestion, Cosmic. In OBS you can have a text. Do you know how to do that? I don't. But if you can show me how to do that, it would be interesting to set up. I assume it's just another layer, another source, but I don't know how to do it. If you know how, feel free to let me know. M101, one of our local galaxies. Pinwheel. 21 million light years. So not as close as I thought. 21 million. Discovered by Pierre Marchand. It's a pretty one. See how close we are to the line here. Pretty close. Shoot, I did the wrong one first. Who else have we got? Well, we can do M13 next. Wait for this to go over. Pop back over and do that one. What else have we got here? Yeah, this is just way too low. We've already done all of these. Let's see, 6445. These southern hemisphere ones are still a bit too low. Well, I suppose what we could do is try to look for some of the ARP targets. He had some down here at the bottom of his list. He has some the mini Arpathon. Northern mini Arpathon and southern mini Arpathon. Let's go do M13. It's really kind of cool how one arm just goes way off wild. Yeah. Just add a layer for text. Is a layer a source? Display image scene text GDI. Create new. Text. Alright, what does this do? If I do that, it probably has to be display capture. Nothing shows up though. I don't know, I'd have to play with it. management file, enable, transform text. Okay, defaults. Okay, but where does it go? Where does it go? I don't see it anywhere. Doesn't matter which layer I have it, it doesn't show up. Okay, anyway. M101 is done. Let's see if we can, as this one here is going to be, 5394 is too, get you up here. 5394 has not quite crossed yet. So let's do M13. A nice big bright globular cluster. Oh, there it is right there. Look at that. All right. Now this, we're not going to need very much time at all. Globular clusters, especially one so big and bright like this, does not need very much time. It certainly does not need 60-second exposures. We'll try some 15. We'll try 15. Let's see how that works. Messier 13, the great Hercules star cluster. Come on. Ha! Great big guy. Globular cluster of several 100,000 stars in Hercules, discovered by Edmund Halley in 1714, cataloged by Charles Messier in 1764. Messier 13 is often described by astronomers as the most magnificent globular cluster visible to northern observers, about 1/3 of the way from Vega and Arcturus, 4 bright stars. Messier 13 may be visible to the naked eye with averted vision on dark nights. Messier 13 is prominent in traditional binoculars as a bright round patch of light. At least 4 inches of telescope aperture resolve stars in M13's outer extent as small pinpoints of light. However, only larger telescopes resolve stars further into the center. The cluster is visible throughout the year from latitudes greater than 36 degrees north, which is why I can't see it. With the longest visibility during northern hemisphere spring and summer. Yes. About 145 light years in diameter. It's composed of several 100,000 stars, with estimates varying from about 300,000 to over 500,000. The brightest star in the cluster is a red giant. M13 is 22 to 25,000 light years away from Earth, and the globular cluster is one of over 100 that will orbit the center of the Milky Way. So it's one of our satellite globs. Globular clusters tend to orbit. They're large collections of stars that tend to orbit the Milky Way, which is why one of the theories about what they are is that they're basically other galaxies that the Milky Way has captured, and with its gravity has stripped most of the outer stars away from the galaxy, leaving only the core of the galaxy itself, which is a globular cluster. So there's quite a few that orbit the Milky Way and other galaxies as well. Almost all galaxies have satellites. It's a pretty cool glob. There's a lot of stars in there. Then we got these guys. Alright, well, the nice thing about globs is you don't have to take a whole lot of time on them. They're big and bright and resolve quite well, quite quickly. Okay, 5394, so now we gotta flip back over the meridian again. Alright, where are you? There you are. Alright, let's plate solve on this. Okay. Well, we did a planetary nebula at the very beginning, after we've done 2 planetary nebulas so far. But it is galaxy season, so mostly what we're doing is galaxies. But there have been a couple. Are there any others? These are all mice galaxies. The Ghost of Cassiopeia. Yeah, that's a nebula. That's way too low. This is Flaming Star, which is a winter nebula. At least when you're as far south as I am. For really northern folks, it's not that big a deal. But for me, it's way too low this time of year. That's a wintertime thing for me. Yeah, well, they're hit to 6445, the little gem. We might get that after we do the this galaxy here. These are so the Lawn Sprinkler Nebula, we did that one already. The 8 Burst Planetary Nebula, we did that one earlier. Oh yeah, look at there. There we are. Okay, so this is, what are we doing now? The Heron galaxy, 5394. 5394. 5394. Barred Spiral. About 175 million light years away. Discovered by William Herschel. So this is 2 galaxies. We've got 1 and 2, and they're gravitationally interacting. Perhaps colliding, but gravitationally interacting at least. Oh, we can get this better situated than this, I think. Now there's two galaxies here that are actually coming together. Oh, thanks for the thumbs up, guys. Appreciate those. I see I've gotten a few more. So thanks everybody for the thumbs up. Let's see what else we've got. These 2 galaxies are a pair of gravitationally interacting galaxies. Doesn't really say much about it. 107 million light years. Okay. Which corresponds to a Hubble distance of 175 million light years. To date, the non-redshift-based measurement gives a distance of approximately 107 million light years. But the Hubble distance is 175 million light years. I don't know what that means. It's a ways away. It's a ways away, anyhow. These two guys. Is it that much easier to do live stacking in SharpCap compared to other stacking software? I've never used any other stacking software. I've never used like an ASI Live or anything like that. I've only used SharpCap, so I think it's pretty easy. But SharpCap is a very large, complex piece of software, so it's very powerful, but it's pretty complex. So it definitely has a learning curve associated with it. You definitely do need to take your time and learn. But yeah, in terms of EAA and live stacking, I think it's the best software that's out there. So yeah, if you're going more to the astrophotography side of things, long exposures, going all night, pre-programmed sequences, that kind of thing, then you're probably better off with Nina. But for EAA, live stacking for EAA purposes, SharpCap is definitely the way to go. Yeah, if you want to make them perfect, yeah, you can go with, Hickson Sight and Blur Exterminator and whatnot, and spend a lot of money and get the best images you can. Personally, I'm not into that. I don't care about getting the best images. I just like seeing live images. So I don't do that kind of stuff. But yeah, you can Photoshop it. You can use Hickson Sight, which is kind of the flagship software for doing this kind of doing astrophotography. But that's overkill for my purposes. No, I don't use any mini computers. I'm just sitting behind. I'm just sitting at a table behind the scope with a laptop, controlling all of this. So, no, there's no mini computers on the mount or the scope. And I don't use Nina. I just use SharpCap. They're coming up pretty decent. Got some detail in that. Yeah, I control everything from within SharpCap. The mount controls are here with the plate solving and You know, I can actually manually move them out if I want. Control the tracking here, control the slew rates. And then this controls the camera. So all the camera controls, and then the capture stuff is there's one histogram here, and then for the live stacking there's another histogram in here, which clearly needs to be adjusted because I haven't done that in a while. Cool. But yeah, and if you have an EAF or auto rotator or any of those kinds of things, SharpCap can also control those as well. I have an EAF, I just don't use it because I sit out by the scope. So, you know, my C8 is, I just got one of the large wheels for the focusing knob, and so I find it very easy to manually focus because I'm sitting out here anyway. Why not? So, but yes, SharpCap can control all this stuff. It can do it all. It's more geared to the EAA side, as I said. Short exposures, spending a little time on it, really designed for live views. It's really designed for EAA. If you're going to be going to astrophotography and doing lots of time on an object, long exposures, maybe running sequences, running overnight with capturing data, that's where you start wanting to go toward Nina. Nina is much more set up for AP. SharpCap is much more set up for EAA. There's a lot of crossover between the two, but that's generally the way you want to go. So depending on what you're looking at doing, one software versus the other is usually preferable. Okay, so it's 6445. Where are you? Boy, can I see you yet? It's close. Well, I can try slewing to it and see where we get. 6445, a little jump. Where am I right now? I'm on the west side. Ooh, you know what? Ooh, Omega Centauri. I have to try for it. We'll give this a little more time. We'll give this guy a little more time to rise. Let's go do Omega Centauri and Centaurus A. Those I don't. Not many people can do those in the northern hemisphere, and it's pretty low for me, but it's doable. And I'm already on the correct side of the meridian for it, so let's just go for it. It was a degree or two higher earlier, but oh man, scope is pointing right by my head. Right by my head. It's not able to find a solution. Why am I getting no? I'm not seeing any stars at all. Hold on a second, let me go behind the scope and see what it's... Sure why we're seeing nothing. Everything looks like it's... Try increasing the exposure a little bit, see if I can pull anything in. I have something here. Oh, there we go. Now we've got a couple of stars. Looks pretty mushy. Okay. Let's go up to Centaurus A. See if I can see anything there. Okay, well I have objects here. I may not be able to plate solve on it. I may have to, yeah, it's all looking really mushy. It's so low. It's looking just really mushy. So images may not be great on this tonight. Let's see what happens. Usually I can do a fairly decent job on it. It's never very high off my horizon, so it's always a bit iffy. But usually I can get something. Let's see what we can see. Yeah, we can see it. It's not great, but we can see it. Everything's a little mushy, but it's there. Not exactly centered on it either. But it is there. Stars are a little mushy and whatnot, but hey, we got it. This is 5128. Centaurus A. Discovered in 1826 by the Scottish astronomer James Dunlop from his home in Parramatta, New South Wales. Gonna say, you're not gonna see this from Scotland, that's for sure. He is from New South Wales, Australia. Considerable debate in the literature regarding the galaxy's fundamental properties, such as its Hubble type and distance, 11 to 13 million light years. It is the closest radio galaxy to Earth, as well as the closest BL-LAC object, so I don't know what that means. So its active galactic nucleus has been extensively studied by professional astronomers. The galaxy is also the fifth brightest in the sky, making it an ideal amateur astronomy target. It is only visible from the southern hemisphere and low northern latitudes. The center of the galaxy contains a supermassive black hole with a mass of 55 million solar masses, which means it's 55 million times the mass of our Sun, which ejects a relativistic jet that is responsible for emissions in the X-ray and radio wavelengths. Galaxy. And it's only a few degrees above my horizon right now. It's just a little under 10 degrees above my horizon. A little mushy, as it always is. But I can see it. There, I just did it old school. Oop, come on. Grab, there we go. No, you're not kidding, because you're right. I don't really know. I mean, I'm sure there's keyboard shortcuts to do this, but I don't know what they are. Of course, now this is blindingly bright white, which is not ideal, but if I could figure out how to do it in OBS, I would, but I can't seem to make a text layer show up, so clearly don't know what I'm doing. In OBS, at least. But hey, we're going to get 10 good minutes on Centaurus A, so that's kind of cool. Where am I from? I am, well, from the Death Valley region of California. So, eastern, kind of southeastern, eastern California. I live out in the middle of the desert. I'm 80 miles directly west of Las Vegas. This is the best way to get an idea of where I am. Find Las Vegas on a map and go about 80 miles west, and that's where I am. Alright, we'll do one more sub on this, and then I'm going to go try back. I'm going to try to go back to Centaurus, or Omega Centauri. I'm going to try to go back here. I won't bother to try and plate solve. Just dead wrecking it. Should get close enough. It's a pretty bright object, so shouldn't be difficult to locate. Alright. Centaurus A. Cool to be able to get it. Okay. Let's see about... We're back down here. Go even lower on the horizon. Just... start imaging. It should be in the field of view. It's a very short slew. But we'll see. It's really close. This is only 5 degrees above my southern horizon. Really, really low. I wish I'd gotten it an hour ago. Didn't think of it though. Well, we had a list. We had a list to accomplish, and these are just extras. Yes. Stovepipe Wells, Park Village, Furnace Creek, those are all inside Death Valley. So, if you know where those are, then, hey, look at that. Look at that. Omega Centauri. And back it off a little bit, then. Here's a big old, it's not exactly centered, but it's close enough. This one is even bigger than M13. Very yellow, though. Quite yellow. Now it's a little pinkish. Knock some of the red down a tish, maybe. It's getting close. It's getting better. The colors are wonky down this low. I'm only 5 degrees above my horizon, so everything's a bit wonky and mushy. The telescope is basically pointing almost completely level right past my head. But yeah, now the guider is complaining because it's probably being blocked by who knows what. The guiding is going to be just horrid down here because it's all just mush. But that's okay. The fact that we can see it is pretty much a miracle. We'll just spend a couple of minutes on this, and then we'll go see about getting 6554, and I think that'll be 6445, sorry. I'll see if I can get this. It still might not be high enough. Yeah, it's going to be close. It's going to be close. Maybe. I don't know if it's high enough yet. Maybe. We'll give it a shot. In the meantime, we'll just enjoy Omega Centauri. Oh, you're very welcome. I appreciate you being here. And taking the time to chat. It's always nice when folks chat with you. Alright, I think that's probably going to be about all we're going to get on that sucker. Another very cool. Let's see what 5139. I didn't actually look this up. 5139 Omega Centauri. Globular cluster, Edmund Halley in 1677. It's 17,000 light years away. It's the largest known globular cluster in the Milky Way at a diameter of roughly 150 light years. It's estimated to contain approximately 10 million stars with a total mass of 4 million solar masses, making it the most massive known globular cluster in the Milky Way. It's very different from most other galactic globular clusters to the extent that it is thought to have originated as the core remnant of a disrupted dwarf galaxy. 10 billion stars. One of the few globular clusters visible to the naked eye, and it appears almost as large as the full moon when seen from a dark rural area. It's the brightest, largest, and at 4 million solar masses, the most massive known globular cluster associated with the Milky Way. Of all the globular clusters in the local group of galaxies, which means it's all of our local galaxies, only Maial 2 in the Andromeda Galaxy is brighter and more massive. Orbiting through the Milky Way, Omega Centauri contains several million population 2 stars and is about 12 billion years old. The stars at the core of Omega Centauri are so crowded that they are estimated to average only 0.1 light-year away from each other. Meanwhile, our nearest star is 4 light-years away. The internal dynamics have been analyzed using measurements of the radial velocities. Looks like it has an intermediate mass black hole at the center of it. Pretty cool, though. Alright, let's see if we can pick up 6445. The Little Gem Nebula. Alright, big slew all the way across the meridian again. And all the way back. Scope is doing lots of slewing tonight. Back and forth across the meridian. Usually I try and plan it a little better than this. But so many of these objects are really low objects. Some late rising. Well, honestly, a lot of these are just intended for Southern Hemisphere anyway. Alright, I'm going to go see if this is actually pointing at the building or if it's looking at sky. Well, it looks like I'm looking at the side of the house, but I don't know. Maybe not. Maybe we can catch it. Let's see what happens. It says it's right on. Boy, that big slew, and it says it's right on? Okay. Okay. Let's see if we can see anything. Let's see if we can see it. The Little Gem Nebula. 6445. Okay. The Little Gem, or Box Nebula, is a planetary nebula in Sagittarius, discovered by William Herschel in 1786. The distance is estimated to be slightly more than 1,000 parsecs. Love it when it does that. Which means 4,500 light years? Yeah, 4,500 light years away. see here. Oh, I'll be darned. We can get it. It's cleared the roof. And there it is. There it is. A little box. Okay. We got it. We better balance these colors off because they're wackadoodle. Alright. Cool. Well, there it is. The box nebula. It's a bipolar planetary nebula. In optical images, NGC 6445 features a bright central ring-shaped morphology and open bipolar lobes. It has an irregularly shaped central region. It's about 4 light years across and is among the largest known planetary nebula. 4 light years across. That's a big planetary nebula. That's a big nebula of any kind. 4 light years. That's many hundreds of times the size of our solar system, if I have that correct. Cool. Well, very colorful. Lots of colorful stars. It's very small, though. It is very small. Hi, Ryder. Well, we were going mostly off a list, so not a whole lot of surprising finds tonight. We did do a few bonus objects. Centaurus A is always a great galaxy to do, and we just did that a little bit ago, so that's always nice to get. Omega Centauri was nice too to get the object, but it's so low on my horizon that it was pretty mushy and discolored, but I got it at least. So, yeah, but the list itself was, we got pretty much everything on the list that I collected anyhow. The only one that's left is, I think from the list that I had was 6334 down here. But that's too low for me right now. It won't rise won't clear my building here for another while. So 6445 here. This nebula is the last thing that I'm doing for tonight, and then we'll see about tomorrow night. Tomorrow night is also looking like it's going to be a pretty nice night. So I may do another one tomorrow night. We'll have to see. So there were a few good things that we saw tonight. Good, some nice star colors in here though. If I get my saturation at, it's up a bit. Yeah. Yeah, well, after I get finished here in a little bit, you can go through and watch the whole thing from the start. And yeah, we get to see a number of neat things tonight. Lots of small objects, so but a few larger ones too. M13 is always nice, the Great Hercules cluster. So that's always a good one to get. Big spectacular glob. And then a whole handful of galaxies. Some interacting and interesting and misshapen, and some just regular old straight up galaxies. But yeah, there's 10 minutes on the box nebula. So the biggest planetary nebula we are aware of, 4 light years across, which is a pretty darn big planetary nebula, especially with how bright it is. It's amazing it's staying illuminated like that. But in any event, I am going to call it a night, folks. Thank you for being here. I hope you enjoyed yourself. Got to see some nice stuff. And I will see you next time, possibly as early as tomorrow night. We'll see. No promises, but I may do this again tomorrow night if the weather holds out and I hold out. So, anyway, until next time, thanks everybody, and we'll see you again.